Hello everybody, today we'll be doing score of parentheses. Given a balanced parentheses string S, return the score of the string. The score of a balanced parentheses string is based on the following rule. If it open and close parentheses, it has a score of 1. If you have A plus B, then you add the parentheses. So, like so, you would get 2. And so, you would get 3. Now, if you were to wrap the items, then you would have wrapped it twice here. Wrapped it 3. So we have 3 items and we wrapped it twice. Or let's just wrap it once for effect. So basically, we're going to take everything inside and multiply it by 2. So we have 6. So how do we keep track of this? When we think parentheses and opening and closing, immediately our attention turns towards a stack. Let's think about some edge cases first. So edge cases are S is a balanced parentheses string, so there are no invalid options. And we also have S is equal to the length of string, which is 2. So basically, this is the base case right here. And without edge cases, and if we use a stack, then the time is going to be O of n. And because of the space, because we're doing every parentheses length of string essentially, and space-wise, we could, in theory, collect all the items in our stack. So this would force us to collect many items into a stack. This is a case where we multiply this middle item every single time we see a closing parentheses, and so on and so forth. We close it many times, so this will become 1 times 2, 2 times 3. This is, as you can see, a 2 to the power type function. Interesting. Okay, well, I wonder what this returns was the right answer for this. Let's put in the console and find out. Run the code. Oh, let's return something, and just for curiosity, let's run it. Yeah, to the 9, 10, 1024. Okay, so that teaches us something about this right here. So actually, what we are doing is building a balance of times we multiply by 2 or we add by 1. And so this means that we can actually do this in O of 1 without a stack by counting the number of balances that we have and adding the item at this point in time with this. So we can do this in O of 1. Otherwise we can do, because only pointer needed. Otherwise we can do space of O of n time if we want, because we can collect all the parentheses and add it up per parentheses. Like if the previous item was a opening parentheses, then, I mean, if it was a closing parentheses, then we just have to sum up the values in the stack. Here's what I mean. So let's start off with a 0 item, and if we have an opening item, then we have another 0. Once we have a closing item, let's say we have a closing item here, what this does is that we pop this item, and we want to determine if this item was a 1. If it was a 1, that means that we could multiply it by 2, but this is a 0, so we set it as a 1. And now, with that, we were able to return, popping this answer off, we would be able to return a 1. Do you know what I'm getting at? Or let's try this one. So with this, we have two items. We have the opening parentheses and the closing parentheses. I mean, we have two opening parentheses at the beginning. And so let's say we had 0, right? So we start with 0 and we add another 0 in, right? And so once we have a closing parentheses, we set this as a 1. What happens when we have another closing parentheses? We multiply this by its value and reset this as a 2 down here. And now we have a 2 that we can return. Okay, you still didn't get it. We can do 3 items now. So, okay, so the first item, let's say we got the first item here. Let's start with a 0. Then we add another 0 and another 0 in, right? So now we get our closing items. So we close the first one, we have a 1, right? So now we close the second one, we pop this, we multiply it by 2, and we add it to this this part here. So now it's going to be 2. Then we take this part and we multiply it by 2 again. We add it to the previous part, and now we have 4. So if we had a number, we would multiply it by 2. If we did not have a number, we would add a 1. The reason for that is because we are opening and closing. So because suppose we have open, close, open, close, open, close, we would have 1. We had open, close would give us 1, and then we have an open, close, which is a 0, and then we give us 1, and then 1 plus 1 is a 2. Then we have another open, close, which is a 0, and it turns into a 1 after we pop it, and then we get a 3. Did you get it? I'm not sure if you got it. Let's just go through the code. This time, match, we can do balance or a stack. So that's the plan. The plan is A for balance, capture the balance, and use bitwise to add each item in place. So we're gonna get the total. We're gonna get this bitwise immediately. We're gonna sum this item up once we get that 1, and we're gonna turn it into a bitwise of 2 to the 10 because that's our balance, and we just compute this and add it to our total sum immediately. For plan B, for stack, add the previous value by 1 or multiply if 0, else multiply by 2. And the reason why we do this is because we evaluate each particular point in time. We evaluate this is a 1, then we add 1, that's going to be 2, add 3, it's going to be 3, and then we're going to do a multiply at the end once we close it. Because we have 3, we know that we need to multiply. Okay, let's get it. So we're going to create a stack. Let's try an empty stack. And what's next is that we're gonna do every value in the string. So for C in string. So if the C is equal to an open parentheses, what happens is that our stack is not gonna append a 0. Otherwise, well, stack dot pop. We're gonna pop an item, and that's gonna be our like next item. And what happens with the next item is that, or previous item, because in this case it's like this item here that this item here that we're popping. When we have this, when we have this, we're actually popping this item. So the middle value, next value, the value, enclose the value. Okay, let's call it the enclosed value. So enclosed value, so we need a total sum, which is going to be stack minus 1. It's going to be, let's start this as 0 because, the first one has to be like 0 because we popped the next item. So we're going to set this as equal to plus equals to the max between 2 times the enclosed value, or it's going to be 2 times 0, which is going to return 1. And then what happens at the end is that we're going to return stack dot pop, last item. With that, we are ready to go. Let's run the code. And we are good to go. Let's submit. And we have a pretty okay answer here. Let's do the balance solution and clean up this code. Yes, this does use O of n time because we're doing every item. And the space-wise, we are collecting all the parentheses, as you can see. So, as you can see, we're collecting parentheses here. Like right here, stacking zeros. And then resolving them. So we're resolving things one at a time. Now, let's do the balance. So total sum in balance, start at 0, 0. What we're gonna do here is that we're gonna just go through the string and we're not gonna collect any items. So for n, for I, and let's say C in enumerate string, what we're gonna do is we're gonna get our character. So if character equals an open parentheses, that means our balance is plus equals 1. Else balance is minus equals 1. We're going to reduce the balance. And our total sum is equal to 1 plus equals 1. And bitwise, how the balance that we have. And with that, we would be able to find out how much balance, and we're computing it at this point in time. So if there's another one, right, like this, we would compute that one immediately next with the total balance that we have. So we're computing it here and here. So this would be like 2 times 1024 times 2, basically. Okay, or what, 1024 plus 1024. All right, so what's going to happen here is that we're going to return the total sum. I think that should do it. Let's check it out. We have 1027. That is not good. Maybe I made a mistake somewhere, and we are overdoing it. Give me a moment. So here was the problem. The problem was that I did not do a if si minus 1 is equal to a opening parentheses. The reason why we need to do this is because if the closing parentheses, if it's a closing parentheses, it has to match with an opening parentheses, but that doesn't make any sense to me. Like, so it works. So what happened was, we have a lot of closing parentheses, don't we? So we have a closing parentheses, but we're not closing anything. We're just closing values. I see. Because we're not closing values, we have to have this before we close because we're closing nothing extra. So let's submit. This should work. And we have a similar answer. Nothing much has changed. That's all good. But this should be O of 1 because we are not using a stack anymore. But this is very hard to, I don't know how, this seems like a very difficult solution to come up with. Because it comes with a different type of logic where we add this particular point after collecting a balance. And that's just something that you have to see before, and you can basically see it next time when you see the same issue, or this same problem, then you can bring it up. Because it's really, if you have the patterns that we have developed was the stack, and there's, how we solve this problem is going to be using a stack, generally. Not like this, where we see a closing and then we match it with the opening, and then we add all the balances together at that point in time at every single spot, which is pretty interesting to me. Well, if you have code that you would like to share, please comment below. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much. I'll see you in the next one.